Hi, folks. We're going to take a look at page 428, number 8. So quite a lot of information here. So we'll look at the question and try to draw the diagram as we go along. So Rocco and Biff are two koalas frolicking in the meadow. Okay. So a piece of eucalyptus falls down and they give us some information as to where everybody and everything is relative to each other. So Biff glances at Rocco, who appears to be 15 meters away. So if I, put this spot here as being Biff, and then somewhere here is Rocco. All right, and that's distance is 15 meters. Okay, and then he looks at the eucalyptus, which is 18 meters away. So make it a little longer. So there's the eucalyptus, and that distance there is about 18 meters. All right. And then it says that from Biff's point of view, Rocco and the eucalyptus are separated by an angle of 45 degrees. So from this perspective, the angle heading towards the other koala and the piece of eucalyptus is 45 degrees. All right. And so now they say that Rocco's top running speed is 1 meter per second, but so Rocco is 1 meter per second. Rocco can run 1.5 times as fast, so that makes that 1.5 meters per second. And it says, can Biff beat Rocco to the eucalyptus? All right. So what we're going to do is we're going to calculate the time it takes each of them to get to the eucalyptus. All right. So we can already calculate Biff's time because we have the distance and we have the speed. And so from there we can calculate the time. So for Rocco, though, we have the speed, but we don't have the distance. So the first thing we're going to have to determine, which I don't think is too surprising, is the distance between Rocco and the piece of eucalyptus. All right, so get rid of the textbook here. We have all the information. So again, so much of these questions where the diagram is not given is just to understand how the diagram works. All right. So let's start by finding x. And so here I do not have any angle opposite side pairs, so I'm going to be using the cosine law. So here x is opposite to the known angle, so I'm going to have x squared equal to, what do we have here? We have the sum of the squares of the other two sides, so 15 squared plus 18 squared minus 2 times the product of the two other sides, so 15 times 18 times the cosine of the opposite angle to x, which is 45 degrees. All right, so essentially x is just going to be equal to the square root of this whole thing. All right, and let's calculate that. All right, so let's get trusty calculator. It's in degrees, so we're good. So we have the square root of 15 squared plus 18 squared minus 2 times 15 times 18 times cos of 45, and we have 12.93. Okay, so the distance there is 12.93 meters. All right, and so now we have enough information to calculate the time it takes each of them to reach the eucalyptus. Okay, so if we take Rocco first, all right, let's first of all remember the relationship between speed, distance, and time. So speed is equal to distance over time. And what I'm looking for is a time value. So I'm going to multiply t to the other side. And then to isolate t, I divide by v. All right. Now, well, some of us know these three relationships, okay, on their own. If you don't know them really well, not a bad idea to go through the steps just to make sure you're doing the correct division and you're not accidentally doing, say, speed divided by distance. All right. So now for Rocco, let's do time is equal to the distance he travels, which we just found was 12.93 meters over the speed, which is 1 meter per second. Okay. So I guess in math, we don't necessarily expect you to put the units at each step. I know in science classes they do, so you can decide what to do. And this is really easy. It's just 12.93 seconds. All right, so now let's do the same thing for Biff and see how that goes. So here we've already isolated t, so t is equal to the distance that Biff has to travel, which is 18 meters, divided by his speed, which is 1.5. And so the time here is 18 divided by 1.5, whoops, 1.5 is equal to 12. All right, so that's 12 seconds. So can Biff get there before Rocco? Yes. So yes, Biff can get there first. All right, and there's our solution. So let's just recap. So again, step number one was to read the question very carefully and make sure that we had a diagram that correctly displays the information. Okay, number two, we realized that what we were missing was the distance that Rocco needed to travel. So that's why we found this side of the triangle. And then from there, this is one of these relationships that we really need to know, which is the speed, distance, and time relationship, which we use to calculate the time for each. And we realized that Biff could get there in a shorter time. Now, one of the things they ask us is, what assumptions are made, and there's a whole bunch of assumptions that are made. First of all, we're assuming that they're traveling at constant speeds. Okay. The other assumption I'd say we're making is that they both see the eucalyptus at the exact same time, and they both start running at the exact same time. Maybe Rocco had actually seen it earlier and got a head start, or maybe Biff saw it and would have gotten there even sooner than that compared to when Rocco was going to get there. So there are some um, uh, uh, assumptions we're making. Maybe another one could be that neither of them have any big obstacles that they have to go around in order to get to the eucalyptus. Okay, so that's it for this one.